We started this playlist by asking a simple question: what is electromagnetism? 20 lessons later, we have explored electric fields, magnetic fields, wave propagation, material properties, power transfer, losses, and antenna fields. Now it's time to connect everything together and see how these concepts form the foundation of RF engineering. At the beginning of this playlist, electromagnetism may have seemed like a collection of separate concepts: electric fields, magnetic fields, Maxwell's equations, wave propagation, polarization, reflection, dielectric materials, and antenna behavior can initially appear unrelated. However, RF engineers do not study these topics independently. In real systems, all of these phenomena occur simultaneously. Every wireless link, antenna, transmission line, radar system, and communication network relies on the interaction of these electromagnetic principles. The challenge is seeing how all the pieces fit together. Understanding these connections transforms electromagnetism from a set of equations into a practical engineering framework for designing RF systems. The central idea of electromagnetism is that electric fields and magnetic fields are fundamentally linked. A changing electric field produces a magnetic field, and a changing magnetic field produces an electric field. This relationship is captured by Maxwell's equations, which provide the foundation for modern electromagnetic theory. From these equations emerges one of the most important results in physics: electromagnetic waves. These waves propagate through space, carrying both energy and information. Their behavior depends on material properties such as permittivity and permeability, as well as interactions with boundaries, conductors, dielectrics, and the surrounding environment. Intuitively, the entire playlist can be viewed as a story of energy transfer. A transmitter generates electrical energy, which creates changing electric and magnetic fields. These fields combine to form an electromagnetic wave that travels through space toward a receiver. Physically, the wave encounters materials, reflects from surfaces, refracts through media, experiences attenuation, and interacts with antennas. Along the way, conductor properties, dielectric properties, polarization, impedance, and loss mechanisms all influence system behavior. Mathematically, every phenomenon we studied can ultimately be traced back to Maxwell's equations. Whether analyzing wave velocity, standing waves, power flow, or antenna radiation, the same electromagnetic principles govern the behavior of the system. Everything in RF engineering begins with electromagnetic fundamentals. Antennas radiate because changing currents create electromagnetic waves. Transmission lines guide energy because electric and magnetic fields propagate along controlled structures. Wireless communication works because electromagnetic waves can transport information through space. Engineers use concepts such as wave impedance, polarization, reflection, and propagation to design reliable communication systems. Material properties determine how signals behave inside PCBs, coaxial cables, microwave circuits, and antennas. At the system level, understanding electromagnetism allows engineers to predict signal coverage, optimize antenna performance, reduce losses, improve efficiency, and build the wireless technologies used every day around the world. Electromagnetic theory is often considered one of the most challenging topics in engineering. However, it is also one of the most powerful because it explains how virtually every wireless system operates. A common misconception is that electromagnetism is only theoretical. In reality, every mobile phone call, Wi-Fi connection, GPS signal, satellite link, radar system, and wireless sensor depends directly on the concepts we explored throughout this playlist. With these foundations now established, we are ready to move from electromagnetic theory into complete communication systems. In the next playlist, we will begin Communication Systems Introduction and explore how transmitters, receivers, channels, modulation, and RF architectures work together to deliver information from one point to another. In this playlist, we learned how electric fields and magnetic fields interact to create electromagnetic waves, how those waves propagate through different media, and how they carry energy and information through RF systems. We explored Maxwell's equations, wave propagation, polarization, reflection, refraction, standing waves, impedance, power flow, material properties, losses, and antenna field behavior. In the next playlist, Communication Systems Introduction, we will build on these foundations and learn how complete RF communication systems transmit information from a source to a destination. If you found this useful, like the video, subscribe, and follow for the next lesson.